All right, day 3 of Module 9. So our learning target is that you can apply the 3 theorems for success on triangle similarity to determine whether triangles are similar. So we're just looking and stating whether or not triangles are similar, and there's 3 theorems that we're going to look at with this as well, okay? Okay, so we're going to look at this here. We're going to go through some of these as well. So there are 3, again, theorems or rules that will help us show that triangles are similar. The first one is this angle-angle test. You will see that by AA a lot of times, and we're looking to see whether they're similar. I've got 2 examples, one that is and one that isn't. Okay, so before we get going on this, it's really, really important to remember day 2 that for angle or for things to be similar, we have to have angles, again, that are congruent, and then the sides have to be proportional. And then sides, again, they have to be proportional. Now, again, we usually had to check all 3 sides and all 3 angles, but triangles are a little bit unique. You don't need to know every little bit, all 6 things, all 3 angles and all 3 sides. You just need to know the right information. So the first one is you need to know that 2 angles are congruent. So we're going to look at these triangles and see if 2 angles are congruent. So if I look at this, I've got angle Q, and I'm just going to work right over here. Angle Q is congruent, again, to angle L. Okay, so I've got one angle, so that's good. But I also have angle R is congruent to angle M. And so if I have 2 of the angles, then I don't even need to know anything about the side lengths. And I don't need to know the third angle, but I would know the third angle would have to be because of that 100. All the angles on the inside of a triangle add up to 180. So because I have 2 angles, then yes, I know this is similar. Okay. So if they're similar, I want to write what we call a similarity statement. Again, this is a similarity statement. A similarity statement just states one triangle is similar to the other triangle. So QRS, so if I go Q, that has to correspond with L. And then we went to R. R corresponds with M. And then N. A lot of times it's alphabetical, but sometimes it's not. So just take a look. Q and L, R and M, and then S and N correspond with each other. And by what theorem? This would be the angle theorem. Or you could just write A for this one. Okay? Let's look at this second example. So this second example, a couple things. Whenever we have these crossing, remember from our previous unit, these are vertical angles, so those 2 angles are going to be congruent to each other. So I have angle F is congruent to angle F. But if I look at G, G is not congruent to either S or T, and neither is H. So I only have 1 here, so I don't have enough information. So there's, again, not enough information. So I'd say, no, they're not similar because of what I've been given. I don't have the right information. And if you ever do that on your guys' homework assignment, we're just going to put NA and NA for both of these because they're not applicable at that point in time. Okay? So that's my angle. That's the first theorem or first rule that I have for this as well. Okay? Second rule, I don't need to know. So if I have 2 angles, that works. If I have all 3 sides and all 3 sides are proportional, so this is what we call side, 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 then I know that those 2 triangles are similar as well. So I'm going to look at this first example. We've got these 2 triangles, PQR, and then I also have this other one that's JKL. So if I look at this, I want to write proportional statements with my sides. So I think of it this way. I've got to make sure they're corresponding. I always go the biggest side over the biggest side of the other one. So this would be like 85 over 60. Okay? And I need to check and see if that's going to be equal to everything else. So this should be equal to the middle over the middle. So 77 over 55. and it should be equal to the small over the small. So big over big, middle over middle, small over small. So it should be equal to 42 over 30 as well. And then I'm just going to check them. Again, make sure that you simplify those. This gives me 1.416 repeating. 77 divided by 55 gives me 1.4, and this also, so right now you guys should see a problem. This also gives me 1.4. So these two are equal, but these are not equal. So they all three have to be proportional to each other, not just one. And even though this is really close, it's still not. So I'm going to put no on this. And then if I do that, I always just do NA in these as well. Okay? All right, let's look at this one. This one will probably work, but let's look here. So again, go big divided by big. So I'm just going to go 24 over 36 because that is big over big. Then I'm going to go middle. So 22 over 33 because that's middle over middle. And then, again, this should be equal. And then the last one would be small over small, so 12 over 18. So if I check these are 0.6 repeating. This is 0.6 repeating. And this is 0.6 repeating as well. And so they're all the same, so I'd put yes. And then I have to write my proportional statement, TUV. So T corresponds, again, with K, because it's right here on this point. Sometimes you have to look at the side lengths. T is between the big and the small, so just big and small. So this would be K. And then they went to U. U is between the small and the medium. Small and medium would be L. And then I'd have M. That would be my similarity statement. And then my theorem would be by side, side, side for that. Okay? All right. Looking at the next one. So that's my second one. I've got the angle, and I've got side, side, side. There is one other combo with sides and angles. It is a side, angle, side, and that order matters. What that means is the angle has to be in between the two sides. Okay? And so we're looking for the angle to be congruent and the sides to be proportional. Okay? So if I look at this, I'm going to check my angle out first. R is congruent to J. So angle R is congruent to angle J because it tells me that. So that's good. That takes care of the angle. Now I need the sides. So the sides, I'm going to go big divided by big. So this would be 26 divided by 65. And then that better be equal to 14 over 35. So again, you just have two sides with this, so you don't need to do more than just those two sides for this, okay? So when I do this, these better be equal for it. This gives me 0.4, and I get 0.4, so that checks out for both those two, and so we'd say yes. And then I got to write my similarity statement, PQR, so P it would be L, because it's away from everything, and then Q is right next to that smaller side, so we'd go K, and then J. And then this theorem would be side, angle, side. Notice how the angle is in between the two sides. That's really important for that. Okay? So if I look at this next one, I've got angle A is congruent to angle K, so that checks out. That's good. Then I need to check my sides. So again, big over big. So I'm just going to go 12 over 83, and that should be equal to 7 over 49. If I go 12 over 83, that simplifies to 0.1445, blah, 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 blah. And if I go 7 divided by 49, that gives me something different. I get 0.14. It's good there, but then we go 2.8, so this does not check out. So those are not equal to, so I'd put no, and then we put NA for that as well. So that would be how my side angle sides would work, okay? So again, as I look through this, I've got my three different theorems, angle, angle, side, 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 and then side, angle, side with an example for each one of those. And those are the three rules Instead of having to find all sides and all angles, you just need to find that bit for that. Okay? All right, we'll see you later. Bye.